Good morning, Year 6. I just wanted to say another excellent day worth of work yesterday. You did a really good job of completing your work, but not only completing it, but marking it responsibly and asking for help when it was needed. Well done. Today we're going to continue learning about algebra. We're going to be looking at when algebra is used combining with something called substitution. Before you do that, I'm just going to share my screen. Please make sure that you have a pencil, a piece of paper and a ruler. I would also like to start the lesson by apologising to the error in the maths answers from yesterday's video. On the two-part function machine, I made a mistake with my answers. One of the answers should have been 19, I believe. Anyway, well done to everyone who spotted them. It shows me that you're paying attention carefully to your work, and thank you for bringing it to my attention. Moving on to today's lesson then, we're going to start by going through our morning arithmetic. Please can you pause the video now and answer these 6 arithmetic questions? Okay, so having a look at these questions, firstly, this one was a BIDMAS question. 9 times 2 is 18, add 3 to that and you've got 21. Question 2, convert 2 1/3 into a mixed number, into a top-heavy fraction. 2 times 3 is 6, add 1 is 7. 7 6 subtract 3 6 will be equal to 4 6. You could have converted that to 2/3 if you wanted to, but 4 6 is all you need for the answer. Question 3 is another fraction question, so we make 3/1 into a fraction. We then keep 3/4 the same, we turn divide into multiply, and we flip 3/1 into 1/3. That's 3/12. Again, you could simplify that if you wanted to 1/4 by dividing both the numerator and the denominator by 4. In the next question, you could have just added 2/8 to 2 4/8 to get 2 6/8, or perhaps some of you converted 2 4/8 to make it 20/8 and then added 2/8 to get 22/8. Both answers are completely correct. In question 5, hopefully you were thinking about your part-whole models. I know that when I'm doing addition, I do the part add the part to make the whole. Therefore, the number I'm looking for is the part, and so I need to subtract. 21,801 subtract 7,102 should be equal to 14,699. And finally, 7.813 multiplied by 10. Well done if you use the place value method to get the answer 78.13. I'd now like you to have a look at these daily reasoning questions. Please can you pause the video and have a go at these questions. Here where it says to tick the common multiples, just write down the common multiples, and here where it says circle the numbers, just write the equation that would add together to make 0.99. Okay, going through our answers then, remembering when you're rounding to the nearest 10, you need to underline the 10s and look at the 1s. That's a 5, so it tells you to round up. So please mark your rounding questions. The answers are written there. With your multiples, hopefully you remembered that a multiple is a number which you if I multiply 4 by something, I will get that answer. So if you tick 2, that's actually a factor rather than a multiple. Over here, the only factors, the common factors of 12 and 32 were actually 1 and 2, because the other numbers were only factors of the one of them. Over here, adding together to get 0.99, we'd have 0.9 and 0.09. 0.02 add 0.04, add together to get 6/100ths. To get 1.2, I would have had to add 0.4 and 0.8. We're grouping in the tens column into the ones column, 1.2. And finally, to get 0.35, I needed 0.3 and 0.05. Now, looking at this question of the week in a little bit more detail. We looked at one of these the other day. When you see the phrase Danny thinks of a number, that tells you you're going to be using the working backwards strategy. I draw my question mark to represent my number, but later on, when we're more confident with algebra, we'll be able to give it a letter. Danny thinks of a number. He subtracts 8 and then he multiplies it by 6. His answer is equal to 30. What was the number Danny first thought of? To solve this, I would work backwards using the inverse. Instead of multiplying by 6, I would have to do 30 divided by 6. 30 divided by 6 is equal to 5. Here, where it says -8, the inverse of that would be to add 8. 5 add 8 is equal to 13. Let's go back through the other way and double check that's correct. 13 minus 8, well, that's equal to 5, times that by 6, and that's equal to 30. Yes, well done if you said that the answer there was going to be 13. Okay, I'd now like you to, on your piece of paper, write down today's date and WALT and have a go at the do now questions. Please pause this video to have a go at the do now questions, thinking carefully about how you could present it. There's an example down here where I've written do now, and then question 1, I've just written 6 groups of tea would be equal to 6 tea. Have a go at matching those up, please. Okay, so the first one, if I've got 5 groups of P, that means I've got P 5 times. Yesterday, I saw some of you writing P5. Please remember that the number goes first, so that would be written as 5P. 5 groups of P is equal to 5P. Secondly, if I was doing P multiplied by P, that's P multiplied by itself. Therefore, it's P squared. 5 less than P. Again, this was one of the trickier ones from yesterday. 5 less than P would be, I'm beginning with P and then I'm taking 5 away. P subtract 5. 5 minus P means I'm starting with 5 and then I take P away from that. 5 minus P. P divided by 5. Remember, when you're doing that, that could be written as a fraction. So that's P divided by 5. And I've realised now I've made a mistake and I apologise for that. This one here is the wrong way round. That's 5 divided by P. But actually what I'm looking for is P divided by 5. Well done if you spotted that mistake. The next question is 5 more than P, and that will be written as P add 5. We're going to move on now to look at how we can use substitution to solve algebraic equations. Substitution basically means I've been told what that letter represents, and so I need to substitute it and solve it in the formula. I need to remind myself that 2B means I've got 2 groups of B. I have this sentence at the top and it says, if B is equal to 2, solve the following equation. So if I imagine to myself that B does have the value of 2, here I'm being asked for 2 groups of that. 2 times 2. 2 times 2 is equal to 4. Here I've got B plus 5. If B, as it says above, is equal to 2, then I'm simply doing 2 add 5. 2 add 5 is equal to 7. This one here has got 2 steps. First, I need to do 3B. I know that 3B means 3 times B, and in this example, I know that B is 2. My first step then is 3 times 2, which is equal to 6. My second step is to add 5. 6 add 5 is equal to 11. In substitution, you simply have to swap the letter for the value it's given above. Have a go at these questions, which are similar, but you'll see that the value of B has changed. So for this question, I was looking for 2B, 2 groups of B. If B is 5, 2 times 5 is equal to 10. In this video, I was doing an addition. I know B is equal to 5, so I'm saying 5 add 5 is equal again to 10. In this question with 2 steps, I was looking for 3 groups of B. 3 groups of 5 is 15, and then I'm adding another 5 onto it. 15 add 5 is equal to 20. Well done if you were able to solve those questions. We're going to look now at some slightly more confusing ones. If C is equal to 10, solve the following equation. Now remember, when it's written as a fraction like that, that's the same as saying C divided by 2. C shared between 2 people, or C split between 2. If C is equal to 10, I'm simply doing 10 divided by 2. 10 divided by 2 is equal to 5. Here I need to do a 2-step problem again. 3C means the same as 3 times C. If C is 10, I'm doing 3 times 10, which is 30. My second step then is to subtract 5. 30 subtract 5 is equal to 25. And then finally here, C squared. That means whatever C is, I times it by itself. If C is 10, then I would be doing 10 squared. 10 squared is equal to 100. Can you pause the video now and have a go at solving these questions, which are similar, but the value of C has changed? OK, C over 2 is C divided by 2. 8 divided by 2 is equal to 4. Here, 3 lots of C, well, 3 lots of 8 is going to be 24. 24 subtract 5, this is the bit I somehow got wrong yesterday. 24 subtract 5, I now know is 19. Thank you to the children who pointed that out to me. And C squared, well, C is 8, so 8 squared is equal to 64. 8 times 8 is 64. If you accidentally did 8 times 2 to get 16, just double check you remember what squared means when you're doing it. Okay, sometimes you might have an equation like this where you sort of have to use your BIDMAS knowledge as well in order to know which parts you solve first. I'm going to start this equation by writing BIDMAS at the top to remind myself of the order I must follow. The first thing I do is check if there's any brackets. There are no brackets in this question. I now check for indices. I have indices, so I must solve that immediately. C squared. I know C is equal to 3, so that's 3 squared, and 3 squared is equal to 9. I'm now going to continue working through. I have no division, but I do have multiplication. My multiplication is here, 3C. 3 times C, where C is 3, 3 times 3, that will be equal to 9 as well. I'm now moving on to addition, which I have, and that's not got any algebra in, it's simply plus 4, and the minus goes here. So that would be 9, add 4, which makes 13, subtract 9, which would be equal to 4. Another way you could solve that is thinking to yourself, oh, this is positive 4. This is 9, and here I'm taking away 9. They'll cancel out. I'll be left with just having 4 there. So with this equation, it's exactly the same as when you're using substitution here. It's just you've got to make sure you're following the order of BIDMAS before you solve it. Can you pause the video now and start by writing out BIDMAS and then having a go at solving this question? Okay, well done if you've had a go at solving that one. The first thing I need to do is check for brackets. I have got brackets, so I'll solve both of them immediately. 4 plus C. If C is equal to 6, 4 plus 6 is equal to 10. I now need to solve my other brackets. Within my brackets, there are 2 steps. 3C, well, that's 3 times 8, which is 18, add 1. 18 add 1 is 19. I don't have any indices and I don't have any division. The multiplication I've already done inside of my brackets, so now I'm looking at the addition. 10 plus 19 is equal to 29. Really good job if you were able to follow through all of those examples. I'd like you now to pause the video and have a go at doing these ones. The final 2 questions, question 8 and question 9, are slightly more challenging. You will probably need to write out BIDMAS in order to help you solve those questions. But for all of these questions, you're using the same fact, B is equal to 6. So you've got to remember throughout this video that B is equal to 6 for these questions. Have a go at solving them now, please. Okay, that was the first part of our lesson. We're now going to move on to look at what happens when you've got more than one letter which has different value. In this example then, I've got A, B and C. A is equal to 4, B is equal to 6 and C is equal to 10. It's exactly the same, it's just I've got more than one value I need to substitute. So I'm going to look at my first question here. It says A plus B. Well, I know that A is equal to 4 and I know B is equal to 6. Therefore, I'm simply doing 4 add 6. I know that's equal to 10. Here, it's been written in a slightly confusing way, AC. In algebra, when you have 2 letters next to each other, what that means is you have multiplied them together. AC simply means A times C. Just like 2C would mean 2 times C, or 2A would mean 2 times A. AC means A lots of C. Therefore, I'm doing 4 times 10. If A is 4 and C is 10, AC is equal to 40. Finally, this last one, C is equal to 10 and B is equal to 6. 10 minus 6 is equal to 4. Pause the video now and have a go at doing these questions. And remember, BC is a shortened version of B multiplied by C. Okay, if A is 8 and C is 12, I'm doing 8 plus 12, which is equal to 20. We reminded ourselves that BC means the same as B times C. B is 10 and C is 12. Therefore, I'm doing 10 times 12, which is 120. And finally, C subtract A. If C is 12 and A is 8, C subtract 8 is equal to 4. We might also have questions where we have more than one function we're doing and we need to make sure we're using BIDMAS whilst paying attention to the different values. In these questions, there's at least two things that need to be happening and at least two values you need to pay attention to. In the first question, 2a plus b. If a is equal to 4, 2a is equal to 8. I'm now adding 6 onto that. 8 add 6 is equal to 14. In this question, I'm going to use BIDMAS and first answer inside of the brackets, b plus c. b is 6 and c is 10, so 6 add 10 is 16. I now need to do my multiplication, 3c. If c is 10, 3 times 10 is 30. That means I'm left with 30 subtract 16, which I know is equal to 14. In this question, I'm going to start with my division, c over 2. c is 10. That means I'm doing 10 divided by 2, which I know is equal to 5. I'm then adding b, which is equal to 6. 5 add 6 is equal to 11. I'd like you to have a go at these ones, remembering to use the rules of BIDMAS in order to help you. Please pause the video and try these questions in front of you. C squared is 10 squared, which is equal to 100. We're then adding b onto that. That's 100 add 6, which will be 106. In the second question, you needed to start by solving the brackets. C subtract 2. If c is 10, 10 take away 2 is equal to 8. We're then moving on to multiplication, 5b. b is 6, 5 times b will be equal to 30. 30 subtract 8 will equal 22. Well done if you've been able to do all of these examples in the video. If there were any parts of the video that you found confusing, don't forget you can always go back and rewatch it. I'm now going to explain to you what you should be doing for your independent work. The first set of questions, hopefully you've already answered earlier on in the video. I'm expecting everybody in Year 6 to answer all of these questions down to here. In question 18, you'll see that instead of using letters, we're using symbols. The maths is exactly the same, it's just you're using symbols rather than letters. Believe that is a reasoning challenge. Everyone in Year 6 should try this challenge. If you find it tricky, don't worry, it's meant to be tricky, but you should all be trying the challenge. You have an equation and you are asked to prove whether or not it's correct. That means you'd need to maybe solve the equation, and in this one you're asked to explain why he's wrong. That means you'll need to be writing in sentences. At the bottom, there are 6 questions which I have included for those of you who are feeling very confident with your algebra. It's not expected that you would definitely solve these questions, but I know that lots of you are feeling very confident with this and are enjoying solving the work. Therefore, you could do these questions at the bottom. Please pause the video now and solve the independent work. At the end of this video, I'll go through the answers, but you must make sure you have completed all of your work before you press play again. Please make sure you have finished all of your independent work before you continue watching this video. In a moment, I will be going through the answers, and I want everyone to make sure they have completed their independent work first. Remember, whilst you're learning from home, it's important that you're being as responsible as possible so that we can make sure we know when to support you and how to give you extra help. Okay, for the first set of questions, the first 7 answers are up here. You can pause the video and quickly mark those. I'm then going to go through question 8 and question 9 in more detail as they were trickier. Question 8, I know that b is equal to 6. I had to do b cubed. Now, I know b squared, if I'm doing b cubed, I know that's 6 times 6 times 6. I know that 6 times 6 is 36, but I don't know what 36 times 6 is off the top of my head, so I would have written out my short multiplication to solve 36 times 6. 36 multiplied by 6 is going to be equal to 216. Once I've done that, I'm adding 6b to it. Again, b is equal to 6, so I'm doing 6 times 6. 216 add 36 for that one would have given you the answer 252. That one was a lot trickier, so don't worry if you found it difficult. Just make sure you're watching how I did it. If you need to rewatch that part of the video, watch it again. For question 9, I need to solve the brackets first. Inside of the brackets, I'll solve each side first. B squared is equal to 36. And 4b, that's 4 groups of 6, is equal to 24. I now need to add those together before I've completely finished solving what's inside of the brackets. 24 add 36 is equal to 50. I then need to do the second part of outside the brackets, which was dividing by 2. 50 divided by 2 is equal to 25. Looking at the next set of questions, the first 5 answers are on the board already, and we're going to go through the harder 3 questions now. 2d plus a times b. First, I need to solve my brackets. A times b. If a is 2 and b is 5, a times b is 10. I'm then looking for 2d. d is equal to 3. 2 times 3 is 6. 6 add 10 is equal to 16. So once again, that's 2 groups of d, which is 6, added on to a times b, which was 10, making 16. In the next question, I'll also solve the brackets first. Inside of the brackets, I need to know what 3f is and what 2e are before I can add them together. 3f is 3 groups of 100, so that's 300, added on to 2e. e is 2.5. 2 lots of 2.5 will be equal to 5. So that's 300 add 5, 305. I now need to do the second part outside of the brackets, which was to subtract b. b is equal to 5. Therefore, I'm doing 305, take away 5, brings me back down to 300. And finally, for your last question, you would have needed to use the place value method in order to solve this one. I'm doing 452 divided by f. That means 452 divided by 100. I would use my place value method for this one to ensure I'm getting it correct. I would write out 452 and put my bullet points, my decimal points either side. I'm making it 2 place value places smaller, so I'm going to move each digit along 2 places, leaving me with 4.52. I now need to add on to that 4e. That's 4 lots of 2.5. I know double 2.5 is equal to 10, so 2.5 add 2.5 is equal to 5, so 4 lots of 2.5 will be equal to 10. That means I'm doing 10 add 4.52. That gives me 14.52. If you felt confident with these questions, but you got a little bit lost on question 15, 16 and 17, don't worry. I purposefully included some questions that were harder than anything you'd need to do in year 6, because I know that many of you are feeling confident. If you could do question 10, 11, 12, 13 and 14, that's about as difficult as you're likely to approach in year 6. For these questions here, all you needed to do was replace the symbol with the value. The answers are on the board. You can mark your work now. In the next set of questions, we'll go through them together. Ali said that the answer to the below equation is 17.8. Is he correct? Prove it. What you need to do here is solve it yourself to work it out. I've got 4p divided by m in brackets. That means I need to solve that first, and then I'm adding 2s onto it. First, I'm going to start with 4p, 4 groups of p. If p is 4.5, I need to double that to get 9 and double it again to get 18. I'm then dividing that by m. 18 divided by m, which is 6, will give me 3. Everything in the brackets reduces down to the answer 3. I'm then adding 2s. If one group of s is 7.1, 2 lots of that will be 14.2. I now need to add both of those parts together. 14.2 add 3 will give me 17.2. Was Ali correct? No, he was not. Secondly, it says, Bob says, if A is equal to 4, then Y is equal to 20. Explain why he is wrong. Bob has said Y is equal to 20 and A is equal to 4. In the equation then, what I need to do is have a look at what one side of it would be. 3a. If A is equal to 4, 3 groups of A will be equal to 12. 12 add 5 is equal to 17. But Bob said that Y was 20. Is 20 equal to 17? 20 cannot ever be the same as 17. They're different numbers, and that's why Bob was incorrect. The answers to these questions are just shown here. The answer to this one, I'd just like to point out, the correct answer is 4, but I imagine some of you might not have seen that tiny little negative number. If you didn't see the fact that it was minus 4b, then you might have got the answer 44. But if you did see it with minus 4b, you were doing 4 times b, which was 5. 4 times 5 is 20. If that's minus 4b, that will be minus 20. Add on 3c. C is equal to 8. 3 times c is 24. Minus 20, add 24 will leave me with 4. Well done to everyone who's completed their work carefully over the past couple of days. I've been really, really impressed. I'm looking forward to seeing everyone's work from today and I'm looking forward to seeing everyone's work from today. Keep working hard. You're doing a great job.